to talk to you about enthalpy. Now, enthalpy is going to be all about heat, okay? Enthalpy, we use the capital H, and it is kind of the heat content in a reaction. Here's the problem. We can't actually measure how much heat is in the reactants or how much heat is in the products, but we can figure out how the heat has changed between them. So heat of reaction is what we're going to look at most often, delta H. Now, delta means change in heat. And this is actually, usually when I'm talking about enthalpy, I'm going to be talking about delta H. That's going to be a lot more common, okay? So it's the heat released or absorbed during a reaction, okay? Now, here's the formula for it, but you're not going to do any math. You do have to be able to recognize this formula, though. So the change in heat is the products minus the reactants. Notice this is very similar to the change in temperature. Final minus initial. Oh, I think that's coming soon. So when you do specific heat calculations, you're going to see that that's very similar. Final minus initial is the change. So the products minus the reactants is your change in enthalpy. Here's the key point. This is what you really have got to know. If the change is negative, that means that that reactants had more heat. That means that heat is released. We call that exothermic. Heat's released. Now to us, in a reaction, it's going to feel warm because we're feeling the heat that's released. If delta H is positive, that means that the products have more, and therefore heat is absorbed, and it's endothermic. Endothermic. Exo, exit. Heat is leaving the system. Endo, take it in. Heat is required. Heat is absorbed. You have to add heat to the system in order for the reaction to take place. So here's what you're actually going to have to do with this, okay? So given a reaction and given a delta H, you're going to have to know if the reaction is exothermic or endothermic. You cannot know that a reaction is exothermic or endothermic unless you are given heat in some way, okay? So here we have a reaction. Hydrogen plus oxygen yields water. Delta H is a negative 241. What does that tell us? 0.8 kilojoules. What does that tell us? Delta H is negative. That means that this reaction is exothermic. Exothermic reaction. Okay? Now, here's what's really cool. Sometimes we actually see that the delta H might be off to the side like this. It could also be put in the reaction as a reactant or a product. So let's think about this. If heat is being released, if heat is being formed, produced, released, which would that be? Would heat be a reactant or would heat be a product? Would heat be required and used up, or would heat be produced, formed, released? Definitely would be a product. So if you get a negative number here, we could rewrite this equation. I want you to put this in your notes. H2 plus 1/2 O2 yields H2O plus 241.8 unit kilojoules. So do you see how we just added the enthalpy into the reaction? And you know what that tells us? That tells us if this reaction were to go on, it would release 241.8 kilojoules. So if we could find a way to harness that energy, this reaction would produce some energy that potentially we could use in some other fashion. Now, I usually have some questions. Why in the world would this be positive? Why not be negative? It's a negative number. Have you ever seen a negative number in a chemical equation? No. What would that mean? It produces a negative thing? Okay, that doesn't make sense. So always turn the numbers positive. The very idea that this is as a product tells us that the number is negative. Okay, that's what it means. It means it's released. So one more thing I could add us here. If delta H is negative, heat is released, exothermic, that means that delta H would be a product. Okay? Let's do this next one. So we see H2O plus H2 plus 1/2 O2. By the way, do you notice that this is the exact reverse reaction of this? It's the exact reverse reaction. So, do we see we have the exact same number, but it's the opposite sign? Yeah, isn't that kind of cool? This is how this works. But do you see that this is a positive number? What does that tell us about this reaction? This reaction is endothermic. As we come here, we see that when delta H is positive, heat is absorbed and it's endothermic. So we could rewrite this reaction to get the heat in there, and that would be H2O plus 241.8 kilojoules yields H2 plus 1/2 O2. And you see there we put it as a reactant because this heat is required. So if delta H is positive, that means it's endothermic. And delta H, the heat, would actually be a reactant. So for exothermic reactions, the delta H is a product. For endothermic reactions, the delta H is a reactant. So there's one more thing I want to show you with enthalpy, and it's really kind of a cool thing. And this is what it is. That enthalpy depends on the number of moles on the reactants. However we change the equation, we change the enthalpy in the same way. So it's really kind of cool. Honors folks, seeing this is going to help you with Hess's Law later. Academic folks, I'm getting ready to show you is really just bonus for you guys. You're not going to be required to do anything with this, but I thought it'd be cool for you guys to see. But honors folks, definitely something that's very important, and if you understand what I'm doing here, you're going to really do a great job with Hess's Law a little later, a few slides from now. The next couple videos will be about that. Okay, so what you need to do is, let's first of all look at this reaction. We've got N2 plus H2, 3H2, yields 2NH3. And we see that delta H is negative 91.8. What does that tell us, by the way? That tells us that this is what type of reaction? Definitely exothermic. Why? Because that right here is negative. And if we wanted to put it in the reaction, we would put it as a product, a positive product with units. So that's kind of what I've already shown you on this video. But now what we're going to do is we're going to take, and I'm going to get rid of this actually so that it's not in the way when I'm showing you the next part. But what we're going to do is we know that this reaction produces this much heat or releases this much heat. Now let's look at the next reaction. Do you see how it's still N2 plus H2 yields NH3? It's still the same reaction, but we have different coefficients. Instead of 1, we have 1/2. Instead of 3, we have 3/2. Instead of 2, we have 1. Now some of you might be freaking out because fractions are not allowed in reactions. They don't actually exist. You can't have half of an N2 molecule in reality. But because this number depends on the amount of these, because of that, we have to change it if we change the amount of them. So those coefficients in front now mean more than just a ratio. They actually mean how much we have, which is kind of cool. So you have to compare this reaction to this reaction. What has happened? There's a 1 here and a 1/2, a 3 and a 3/2, a 2 and a 1. Do you see how all three of these numbers is 1/2 of the original number? So what do we do to get the delta H of this reaction? We take the initial delta H and we multiply it by 1/2, or we divide by 2. Why? Because this one is exactly half of this one. So then, when we do that, just to be sure I'm correct, I'm going to use my calculator, divided by 2, we get 45.9. And this is still an exothermic reaction, so we've got to have a negative 45.9. Negative 45.9. There we go. We took this part and divided it in half. So that's what we did here as well. Okay? Let's do the last one. We compared this reaction to the initial. 2NH3 yields N2 plus 3H2. How does that compare here? Oh, do you see how it's the exact reversal of that first reaction? It's the exact reverse of the first. So instead of it being exothermic and having this be a product, it would be a reactant. So it's still the exact same number because the numbers in front match, but it's the exact reverse reaction. So instead of having a negative 91.8, it would be a positive 91.8 kilojoules. There's your answer. And this reaction would now be endothermic. So, there you have it. Thank you for watching.